My name is Ivan, and I'm originally from Kazakhstan. Like many people, I've always had a simple but profound dream to build my own home for my family. Meanwhile, I realized I couldn't wait any longer. We had no other place to live, and I had to act. A home isn't just walls and a roof. It's a place where a family will grow up, where important moments in life will take place. So, I decided not only to build a house, but also to film the entire process, to show how this dream was gradually becoming a reality. The first step was to prepare the site. When I first arrived on this property, it was in a neglected state. The plot was overgrown and uneven, with potholes and elevation changes in places. It became clear that serious land preparation was essential before construction could begin. I decided to start with a soil competition. For this, I had to order a large quantity of soil. Trucks arrived at the site one after another throughout the day. The trucks delivered soil, and gradually the site began to change right before my eyes. Where there had been potholes and uneven areas, a level surface gradually emerged, where our future home would stand. The work proceeded almost non-stop. Trucks were constantly arriving, unloading, and driving away beyond the new party land. It was a rather long and noisy process, but I understood that this was a critical step, without which it would be impossible to move forward. After all the soil had been delivered, the next step was to start working with the equipment again. I hired construction equipment to prepare the site for final leveling. A large machine carefully moved the soil across the entire area, removing any uneven terrain. The site began to take on a completely different appearance. What had recently been overgrown and uneven ground was transformed into a level and prepared site for future construction. At that moment, I especially felt that everything was really beginning. Of course, there was still a lot of work ahead: the foundation, walls, roof, and interior finishing. But any home begins with these first steps: preparing the land and planning the future construction. I decided to film this entire journey to preserve the memory of this process, and perhaps inspire others who also dream of their own home. After all, even the largest construction project begins with small decisions just getting started. And that's how the story of building our home began. There are still many stages, challenges, and exciting moments ahead, but the first step has already been taken. Now, on this site, a house will soon be built with our own hands for our family. When building my house, I try to do as much of the work myself as possible. This not only helps me save money, but also gives me confidence that everything is done well and reliably. One of the most important steps on the site is installing the sewer system. In our region, this system is most often called a septic tank, so I decided to build it myself. First, I needed to prepare the site and dig a hole. Of course, doing this manually would have been very difficult and time-consuming, so I ordered specialized equipment. A specialized vehicle with an excavator arrived on site, and in just a short time, a large hole approximately 2 meters deep was dug. When you look at such a pit, you immediately understand the scale of the work and imagine how the future sewer system will be located here. Once the pit was ready, I could move on to the next step. I decided to fill the bottom with a layer of crushed stone. This is done to create a good drainage layer. Crushed stone helps water drain better into the ground and simultaneously serves as a solid foundation for the concrete rings. I carefully spread the crushed stone over the entire bottom surface to create an even, dense layer. Next, I began installing the concrete rings. These are quite heavy structures, so equipment was essential. The rings were lowered into the pit one after another. I decided to install them in 2 rows, with 2 concrete rings in each. This created 2 separate sections that would serve their respective functions in the septic system. Once the rings were carefully installed and aligned, the next step was to seal the structure from above. Special concrete covers are used for this. They securely cover the rings, making the entire structure strong and safe. One of the covers has space for a hatch, allowing for future maintenance or cleaning of the septic tank. After installing the concrete covers, I installed the hatch. It closes off access to the interior while still remaining convenient for servicing the system. It's crucial that everything is done correctly, as a septic tank is a system that should operate for many years without problems. Once the entire structure was assembled, the final step was to fill the voids around the concrete rings. The sewer pipe will be installed after the foundation. One of the most important stages of any construction project is the foundation. It's where a real house begins, because the strength and durability of the entire structure depend on how well and correctly it's built. In our case, we decided to build a shallow strip foundation. Before starting any excavation work, everything needs to be marked out very precisely. First, we took precise measurements of the future house on the site. I carefully transferred all the dimensions from the plan to the ground, ensuring that every side matched the plan. It's crucial that the foundation be level and perfectly shaped, so the next step was checking the diagonals. When the diagonals match, it means all the angles are right angles and the markings have been completed correctly. This step may seem simple, but it's actually crucial because even a few centimeters of error can impact subsequent construction. Once the markings were complete, it was time to move on to excavation work. For this, I again called in specialized equipment. The excavator began digging a trench along the entire line of the future foundation. We dug a trench approximately 30 centimeters deep. This type of foundation is called a shallow foundation because it doesn't extend deep into the ground like traditional foundations. After the trench was dug, the workers got to work. The next step was preparing the reinforcement. Rebar is metal rods that are tied together to form a framework. It's the reinforcement that makes the concrete much stronger and helps the foundation support the house's loads. The workers carefully tied the reinforcement framework and laid it directly into the trench. By the way, I made a small mistake here, which I want to be honest about. Before laying the rebar and pouring the concrete, it would have been better to line the bottom of the trench with construction plastic. The plastic helps retain moisture in the concrete and prevents cement latents from seeping into the ground. This makes the concrete stronger. Unfortunately, I didn't think about this at the time. It's not a critical mistake, but if I had to do it all over again, I would definitely use plastic. After preparing the rebar, we poured the first concrete section directly into the trench. This created a kind of concrete base. The work wasn't finished. The next day, once the concrete had set slightly, we continued building the foundation. Workers began tying rebar on top of this concrete base again. This created another reinforced frame that will strengthen the upper part of the foundation. We could say that we ended up with a double foundation first, a concrete base in the trench, and then another reinforced belt on top. The next step was installing the formwork. Formwork is special panels installed along the edges of the foundation to hold the concrete in the desired shape. We leveled the formwork and checked the alignment of all lines to ensure the foundation was as precise and accurate as possible. When everything was ready, the rebar tied and the formwork installed, the most crucial moment arrived, pouring the concrete. The concrete was poured directly into the formwork, filling the entire space around the rebar. Gradually, the foundation began to take its final shape. There's another important point that applies specifically to our region. In Kazakhstan, the depth of ground freezing can reach approximately 2 meters. Many people think that foundations must be dug to this depth. But digging a 2-meter foundation would be a so-called golden foundation. Its cost would be enormous. Therefore, a different approach is used when constructing a shallow foundation. To prevent the house from being lifted by frost heave, it's essential to properly insulate the concrete area around the house. An insulated concrete area prevents the ground near the foundation from freezing too deeply. This prevents the soil from expanding and pushing the foundation upward. But we'll address the concrete area insulation a little later, during the next stages of construction. In the meantime, the foundation is gradually gaining strength, which means that one of the most important stages of construction is already behind us. Much exciting work still lies ahead: the walls, floors, roof, and interior work. But it was from this moment that we could say that the construction of our house began in earnest. I was a bit hasty in my previous comment and said that we had already poured the concrete. In fact, the pouring hadn't happened yet. I simply mentioned this step in advance, but the work itself was still ongoing. Currently, we are still preparing the concrete base for the main foundation. This stage is crucial because the strength of the entire future structure of the house depends on it. There's no rush here, so we're trying to do everything as carefully and correctly as possible. Currently, work is underway on the site. Workers are tying rebar. Metal rods are tied together with special wire, forming a strong frame. This structure is necessary so that the concrete can withstand future loads and prevent cracking. At the same time, we are preparing the base of the trench. A layer of crushed stone is poured onto the bottom, after which it is carefully compacted. This is done to create a dense and stable base for the future foundation. Well-compacted crushed stone helps distribute the load evenly and makes the foundation more reliable. After compacting the crushed stone, the reinforcement cage is carefully laid into the trench. Workers ensure the reinforcement is at the correct height and does not touch the ground. Everything must be positioned correctly so that the concrete completely covers the metal cage. So now we are at an important preparatory stage. Tying the reinforcement, compacting the crushed stone, and laying the cage are continuing, and very soon we will be able to move on to the next step, pouring the concrete and forming a solid foundation for our foundation. As I mentioned earlier, the concrete pad for the foundation is completely ready. The concrete has already cured and reached its initial strength, so we can now move on to the next step, preparing the main foundation, which will be poured on top of this concrete base. The concrete pad serves as a good and reliable foundation for the entire foundation. It levels the surface, distributes the load, and makes the structure more stable. Now our task is to properly prepare everything for pouring the main part of the foundation. First, we continue working with the rebar. The workers are tying together a metal frame that will be located inside the future foundation. The rebar is tied together with special wire, forming a strong structure. This frame is necessary so that the concrete can withstand the loads from the walls and the entire structure of the house, and also to prevent the foundation from cracking over time. Proper placement of the rebar is crucial. It should not lie directly on the concrete or touch the ground. For this, special supports are used to raise the frame to the required height. This ensures that the rebar is completely encased in the concrete after pouring and will work properly. The next step is installing the formwork. Formwork is special panels that shape the future foundation. They are installed strictly according to level and markings to ensure that all the walls of the house are level. We carefully check each side to ensure there are no distortions or errors. Once the formwork is fully installed and the rebar is tied and leveled, the foundation gradually begins to take its final shape. Everything is ready for one of the most important stages, the concrete pour. Very soon, the concrete will arrive on site, and we will begin pouring the main foundation on top of our concrete pad. This foundation will support the entire future house. The foundation is completely ready. The concrete has cured and gained strength, so we can now move on to the next step. The first thing we do is carefully remove the formwork. It was this that held the foundation's shape during the concrete pour. Now that the concrete has become strong, it is no longer necessary. We gradually dismantle the panels and free up the foundation around the entire perimeter of the house. After removing the formwork, you can clearly see the results of all the work done. The foundation is level and strong, which means we can move on to the next, very important step, waterproofing. Waterproofing is necessary to protect the concrete from moisture. Soil always contains moisture, and over time, this can penetrate the concrete and gradually degrade it. Therefore, it is imperative to protect the foundation's surface. For this, we use a special waterproofing compound. We apply it with a regular roller directly to the concrete surface. Layer by layer, the concrete is covered with a protective material that creates a moisture barrier. In addition to the main foundation, I decided to build additional concrete pedestals. They will provide additional support and help further distribute the load on the structure. I'll be laying a concrete floor, and these will serve as additional support to prevent the floor from sagging. First, I make small square-shaped forms. These are where the concrete pedestals will be formed. I assemble the formwork from planks so that the concrete will take the desired shape and be level after pouring. Before installing the formwork, the foundation must be properly prepared. To do this, I dig down to a dense, solid soil layer. This is crucial because the pedestals must rest on a solid foundation to prevent them from settling over time. Once the foundation is ready, I place rebar inside each form. The metal rods are tied together to form a framework that will reinforce the concrete and make the pedestals much stronger. Finally, the entire structure is poured with concrete. Once set, the resulting concrete foundations will be strong and provide additional support for the future structure of the house. This is another step toward a reliable and durable foundation for our construction.
Stop! 게임 불성이에요. Stop.
It's impossible to imagine a comfortable life without water, so it needs to be taken care of even at the foundation stage. First, I installed the main water supply pipe, which will eventually supply water directly to the house. Choosing the right depth is crucial. Our region experiences severe winter frosts, and the ground can freeze quite deeply. That's why I installed the pipe at a depth of approximately 2 meters. At this depth, it will be below the frost line, preventing the water in the pipe from freezing in winter. Before installing the pipe, I dug a trench to the required depth and then carefully laid the pipe, ensuring it lay level and without any sharp bends. This is essential for the proper operation of the water supply system in the future. After installation, the pipe was gradually covered with soil, carefully compacting the soil. But I decided to immediately consider another important point, a reserve for the future. Therefore, I installed a second pipe next to the main pipe. It serves as a kind of backup line. If problems ever arise with the main pipe, you won't have to dig a deep trench again and dismantle the site. You can simply connect to the spare pipe. This solution may seem unnecessary, but it can actually save you a lot of time, effort, and money in the future. When you do everything during the construction phase, it's much easier than redoing an already finished site. Now the water pipe is installed, and one of the important stages of utility installation has been completed. We are gradually preparing the site not only for the construction of the house, but also for comfortable living in it. There's still a lot of work ahead, but step by step, our future home is getting closer to reality. Now all that's left is to fill the trench with soil. One of the next steps is laying the plumbing pipe to the well. This is necessary to ensure the house's water supply system operates reliably and without interruption in the future. First, we marked out the route the pipe would take from the house to the well. After that, I began digging a trench to the required depth. It's crucial to lay the pipe deep enough to prevent it from freezing in winter and allow water to flow freely, even in severe frosts. Once the trench was ready, we carefully laid the plumbing pipe along its entire length to the well. When laying it, it's important to ensure the pipe lies level, without any sharp bends or kinks. This directly impacts the reliability of the entire water supply system. After laying it, we checked the connections to ensure everything was done correctly. Then, we gradually began to fill the pipe with soil, carefully compacting the soil to ensure it was securely in place. Now the plumbing pipe has been laid to the well, and another important stage of the site's engineering work is complete. Gradually, all the utilities are taking their proper place, and our future home is getting closer to a full and comfortable life. After we've filled the foundation with clay and installed all the necessary drainage pipes, we can move on to the next important step, preparing the subfloor. First, I install formwork around the entire foundation perimeter. This ensures that the concrete holds its shape and doesn't spread during pouring. The formwork is leveled to ensure the future floor is as level as possible. The next step is laying the plastic sheeting. I cover the entire surface inside the foundation with a thick construction plastic sheeting. This serves several functions. First, the plastic sheeting prevents moisture from escaping from the concrete into the ground, allowing the concrete to harden properly. Second, it provides additional protection against moisture that may rise from the ground. Next, I begin working with the reinforcement. I tie together a reinforcing mesh with a mesh size of approximately 25 x 25 centimeters. This metal mesh reinforces the concrete and makes the future floor more durable. Reinforcement reduces cracking and improves load-bearing capacity. It's crucial that the rebar is positioned within the concrete layer rather than directly on the plastic sheeting. Therefore, I install special supports for the rebar. These raise the metal frame to the required height so that after pouring, it sits in the center of the concrete layer. Once all the rebar is tied and properly positioned, we can move on to the next step, pouring the concrete. The concrete will be poured in a layer approximately 7 centimeters thick. This is enough to form a solid foundation. This layer is called the subfloor. It serves as the foundation for all subsequent work inside the house. Later, insulation, screed, and the final flooring will be installed on top. Thus, step by step, we are building not only the walls and foundation, but also the internal structure of the future home. Each step brings us closer to the moment when our family will have a full and comfortable home here. After extensive preparation of the foundation, utilities, and subfloor, the main building material, aerated concrete blocks, was finally delivered to the site. A truck loaded with aerated concrete blocks arrived early in the morning. There was quite a lot of material, as the walls of the future house would be made entirely of these blocks. Aerated concrete blocks are a popular material in private home construction. They are lightweight, warm, easy to work with, and allow for relatively quick erection. We decided to unload the blocks directly onto the foundation to avoid having to carry them manually later. Using equipment, we carefully lifted the pallets and laid them directly on the foundation along the entire perimeter of the future walls. This greatly facilitated further work, as the blocks were located close to the installation site. Once all the material had been carefully laid out, we could begin preparing the masonry. Even though the foundation was already prepared, several crucial steps still needed to be completed before laying the walls. The first thing we did was thoroughly clean the foundation surface. Dust, small debris, and uneven surfaces can always remain on the concrete. All of this must be removed to ensure high quality and level masonry. The next important step is waterproofing the space between the foundation and the walls. Even if the foundation has already been waterproofed, an additional waterproofing layer must be installed under the first row of blocks. This is done to prevent moisture from rising from the concrete into the walls. To achieve this, a special waterproofing material is laid along the entire line of the future walls. It creates a barrier between the concrete and the aerated concrete block, protecting the walls from moisture for many years. After waterproofing, one of the most crucial stages begins, marking and preparing the first row of masonry. The first row of aerated concrete blocks is the foundation of all future walls. If an error is made here, it will be repeated on each subsequent row. Therefore, this step must be approached with the utmost care. First, we checked all the foundation dimensions and once again ensured that the angles matched and the diagonals were correct. Then we began to determine the highest corner of the foundation. This is where the first row is usually laid. For the first row, a special mortar is used rather than adhesive. This allows for slight adjustments to the height of the blocks and allows for any slight differences in the foundation. The mortar is applied to the waterproofing layer, after which the first block can be laid. The very first block is installed with particular care. It is aligned in several directions: level, wall line, and height. After this, the subsequent corner blocks are gradually laid. Once all the corners are aligned, a construction line is stretched between them. This serves as a guide for laying the entire first row. Now the real work begins. One by one, the blocks are laid on the mortar, carefully leveled with a rubber mallet and checked with a level. It is crucial that there are no large gaps between the blocks and that each block is as level as possible. Gradually, the first row begins to emerge around the entire perimeter of the house. Where necessary, the blocks are cut with a special saw to precisely fit the dimensions. It is the first row that determines the geometry of the entire future house. The speed and quality of subsequent laying depend on how carefully and evenly it is laid. Once the first row is completely laid, wall construction can officially begin. Now, each subsequent row will raise the walls higher, and the house will begin to take shape. Just recently, this spot was just an empty lot, but now there's a foundation, a subfloor, and the walls are being laid. Step by step, our dream of owning our own home is becoming a reality. Reinforcement in the first row is needed to strengthen the walls and make the entire house structure more durable and stable. Aerated concrete blocks are relatively lightweight and warm, but for added strength, the walls must be reinforced. This is especially important in the first row, as it bears the brunt of the house's structural load. First, special grooves must be made in the aerated concrete block. This is done using a chaser or grinder. Two parallel grooves, small indentations into which the reinforcement will be placed, are cut along the entire length of the wall. These grooves are typically located a short distance from the edge of the block. Once the grooves are made, they must be cleaned of dust. This is important because dust can interfere with the mortar's good adhesion to the block. Therefore, the grooves are thoroughly cleaned with a brush or blown out. Next, the reinforcement is placed inside. Typically, metal rods of the appropriate diameter are used. The reinforcement is placed in prepared grooves along the entire length of the wall and carefully bent or joined at the corners to maintain the structural strength. After the reinforcement is laid, the grooves are filled with a special adhesive or mortar for aerated concrete blocks. The mortar completely covers the metal rods, and they are embedded within the masonry. This creates a reinforced belt directly within the first row of aerated concrete blocks. This significantly strengthens the walls and helps prevent future cracks. These seemingly small steps actually play a huge role in the reliability of the entire building. It is precisely these details that make up high-quality and durable construction. Once the first row of aerated concrete blocks has been completely laid and reinforced with rebar, you can move on to the next step, laying the second row. Before starting work, it's crucial to prepare the surface of the first row. Even though we've tried to lay the blocks as evenly as possible, slight unevenness may still occur. Therefore, the surface of the first row is carefully leveled with a special float or plane for aerated concrete block. This eliminates minor irregularities and creates a perfectly flat surface for the next row. However, this option is generally better suited for laying with polyurethane foam. With regular adhesive, you can skip the plane and lay the blocks directly. Unlike the first row, which is laid with cement mortar, the second row is laid with a special adhesive for aerated concrete blocks. This adhesive is applied in a thin layer and allows for more accurate and precise laying. Furthermore, a thin joint reduces thermal bridges, making the walls warmer. The adhesive is applied using a special notch trowel or aerated concrete block carriage. This ensures a uniform layer of adhesive across the entire surface of the block. After applying the adhesive, the second row of blocks is laid. It's crucial to overlap the joints. This means that the second row of blocks should not be placed directly above the first row of blocks. Each subsequent row is offset by approximately half a block. This overlapping joint makes the wall much stronger. First, the corner blocks are installed. They are aligned using a level and a cord stretched between the corners. This cord helps maintain a straight line along the entire length of the wall. After this, the remaining blocks are laid one after the other. Each block is carefully placed on the adhesive and leveled using a level. If minor adjustments are needed, a block can be gently tapped with a rubber mallet. If a block at the end of a row is not the correct size, it is trimmed using a special aerated concrete block saw. This material is quite easy to cut, so adjusting the dimensions is usually straightforward. Gradually, the second row begins to build around the entire perimeter of the house. With each new row, the walls grow higher, and the shape of the future rooms is beginning to emerge. Laying the second row is an important stage because it sets the tone for the precision of all subsequent work. If everything is done evenly and carefully, subsequent rows will proceed much more quickly. Step by step, the walls of our house begin to rise. Just recently, there was only the foundation here, but now the first rows of walls are appearing, and the shape of our future home is becoming increasingly clear. There's still much work ahead, but it's these moments that are especially rewarding, as the construction is beginning to take shape. After the first and second rows of aerated concrete blocks have been laid, work begins to move a little faster. Now begins the main stage of raising the walls to the level of the window openings. Starting with the third row, the laying technique remains virtually the same, but the work becomes easier and faster. Before laying each new row, we always check the previous one. If any minor irregularities appear, the surface of the blocks is lightly smoothed with a special aerated concrete block float. This helps maintain the even geometry of the walls and prevent warping. After leveling, all dust is removed. A clean surface allows the adhesive to better adhere to the block. Next, a special adhesive for aerated concrete blocks is applied to the surface. It is spread in a thin and even layer using a notched trowel. The next block is carefully placed in its place. It is crucial to maintain the joint overlap. This means that each subsequent row should be offset relative to the previous one. This overlap makes the walls much stronger and more stable. Each block is checked with a level. If minor adjustments are needed, the block is carefully tapped with a rubber mallet. Gradually, row by row, the walls begin to rise higher. Particular attention is paid to the corners of the house. Laying each new row typically begins at the corners. The corner blocks are positioned as precisely as possible, after which a construction line is stretched between them. The entire wall is laid along this line to ensure a level finish. Sometimes, blocks need to be trimmed. This occurs in areas where the standard block size does not fit. Aerated concrete blocks are easily cut with a special saw, so trimming them to the required size is usually not difficult. Gradually, the walls rise higher and the future window openings begin to form. In these areas, the blocks are laid to ensure precise dimensions for the future windows. When the masonry reaches window level, the work changes slightly. Here, space must be prepared for the installation of window lintils, special elements that will support the load of the wall above the windows. Thus, row after row, the walls rise to the level of the window lintils. The house gradually begins to take on its true form. The layout of the rooms, windows, and future spaces is now clearly visible. Each new row is another step toward completing the house's frame. In the previous stage, we raised the aerated concrete block masonry to the level of the window openings. Now begins the next important stage, installing the window lintels and preparing the reinforced concrete belt. Once the masonry reaches window level, you can't simply continue laying blocks. A lintel is required above each window opening. It supports the load of the wall above and distributes it evenly along the edges of the opening. Without lintels, the walls could crack or even collapse. In our case, we use special E-shaped aerated concrete blocks for the lintels. They are shaped like a tray, allowing for reinforcement and concrete pouring. This method is very convenient because the blocks themselves remain part of the wall and don't form thermal bridges. First, we lay these E-shaped blocks across the entire width of the window opening. It's crucial that they lie level and rest against the wall on both sides of the window. Typically, a small allowance is left approximately 20-25 centimeters of support on each side. This ensures the reliability of the entire structure. Once the blocks are installed, preparation of the reinforcement begins. Rebar is placed inside these blocks. Metal rods are tied together to form a frame that will reinforce the concrete lintel. This reinforcement absorbs tensile loads and makes the structure much stronger. Once the reinforcement frame is ready and correctly installed, we can move on to the next stage, pouring the concrete. The concrete is carefully poured into these E-shaped blocks, completely filling the space around the rebar. After curing, a strong reinforced concrete lintel is created that will securely support the masonry above the window. Once the lintels are in place and the concrete begins to gain strength, the laying of the walls continues. We continue raising the aerated concrete walls higher, gradually approaching the next important stage, the reinforced concrete belt. The reinforced concrete belt is a reinforced concrete belt that runs along the entire perimeter of the house. It serves several important functions. First, it unites all the walls into a single, rigid structure. Second, it evenly distributes the load from the floors and roof. And third, it significantly increases the stability of the house. For the reinforced concrete belt, we use special U-shaped aerated concrete blocks. They are also shaped like a tray, but they run along the entire perimeter of the walls. These blocks are laid as the last row of masonry. After installing the U-shaped blocks, preparation for the reinforcement begins. A reinforcement cage is placed inside. Typically, it consists of several longitudinal bars connected by transverse reinforcement. The entire structure is tied together with wire to create a strong and unified structure. It is crucial that the reinforcement is located within the future concrete layer and does not touch the blocks themselves. For this purpose, special supports or spacers are used to raise the cage to the required height. Once the entire reinforcement cage is ready, concrete can be poured. Concrete is poured inside the U-shaped blocks along the entire perimeter of the house. Gradually, the concrete fills the entire tray and completely covers the reinforcement. After curing, a strong reinforced concrete belt is created, tying all the walls of the house into a single, cohesive structure. This is one of the key elements that ensures the durability and reliability of the entire building. So, at this stage, we not only raised the walls to window level and installed window lintels, but also prepared the foundation for the reinforced concrete belt. The house is becoming stronger and taking on a more complete appearance. Just recently, there was only the foundation and the first rows of blocks here, but now the walls have risen almost to their full height. With each passing day, the house is beginning to look more and more like a real home, and the next important stage awaits us, the floors and roof construction. We've been working hard on the foundation, walls, and reinforced concrete trusses, and now the house is finally starting to take shape. In our case, the roof will be a classic gable roof, reliable and time-tested. Once the reinforced concrete trusses have fully hardened, we can move on to the first roofing element, installing the wall plate. The wall plate is a wooden beam that is laid around the entire perimeter of the walls. It serves as the foundation for the entire rafter system and evenly distributes the roof load across the house's walls. Before installing the wall plate, we always install a layer of waterproofing between the concrete and the wood. This is necessary to prevent moisture from seeping from the concrete into the wood. After this, the beams are carefully laid around the perimeter of the walls and secured to the reinforced concrete trusses with studs or anchors. It's crucial to carefully align everything and securely fasten it, as the entire roof structure will rest on the wall plate. The next step is installing the ceiling joists. These are wooden beams that will serve as the foundation of the ceiling and simultaneously connect the opposite walls of the house. The joists are laid at a specific pitch and secured to the wall plate. They create structural rigidity and help distribute the roof load. After this, the ridge is installed. The ridge is the top line of the roof, the highest point where all the rafters will converge. We install the ridge board and temporarily secure it to hold it in the correct position. Next, the rafters are installed. Rafters are the inclined beams that shape the roof. They are installed from the wall plate to the ridge. Each rafter is cut to the correct angle to fit tightly against the wall plate and ridge board. The work proceeds gradually. First, the outer rafters are installed to establish the overall roof geometry. Then, a cord is stretched between them, along which all the remaining rafters are aligned. It is crucial to maintain a uniform pitch and ensure that the entire structure is level. Once the main rafter system is complete, we move on to the next stage, laying the gables. In our case, the gables are also made of aerated concrete blocks. These are triangular walls that close the space between the roof slopes. The gables are laid carefully, taking into account the roof shape. The blocks are gradually cut to match the slope angles to precisely follow the rafter line. This way, the gables completely cover the roof ends and give the house a finished appearance. After this, we install additional supports and reinforcements for the rafter system. These can include struts and additional beams, which make the roof structure more rigid and stable. These elements help distribute the load from snow, wind, and the roof itself. Once the entire rafter system is fully secured, we can move on to installing the roof base. First, a waterproofing membrane is laid. This protects the wooden roof structure from moisture that may penetrate under the roofing material. The waterproofing membrane is rolled out over the entire roof surface, starting from the bottom up. The sheets are laid with a slight overlap to prevent water from penetrating the structure. After the waterproofing membrane is installed, counterbattens are installed. These are wooden slats that are attached over the membrane along the rafters. They create a ventilation gap between the waterproofing membrane and the roofing material. This prevents moisture from accumulating inside the roof and allows it to freely escape. Next, the sheathing is installed. These are transverse boards or battens that are attached over the counterbattens. This is where the roofing material will be attached. The sheathing spacing is selected depending on the type of metal roofing. Once the sheathing is complete, one of the most spectacular stages begins, laying the metal roofing tiles. The sheets are lifted onto the roof and carefully laid row by row. Each sheet is secured with special roofing screws and rubber seals. Gradually, the roof is completely covered with metal tiles, and the house immediately begins to look completely different. It feels as if the house's shell is finally turning into a real home. After laying the roof, we move on to installing the eaves. The eaves cover the underside of the roof and give the house a neat and finished look. They also protect the roof structure from wind, birds, and moisture. And finally, we added one more small but important detail, a separate mini roof for the boiler room. This is a small structure that protects the boiler room and adds a more harmonious appearance to the house. Thus, step by step, we completely constructed the gable roof. This was a major and crucial stage of construction, requiring a lot of work and attention to detail. Now the house has a reliable roof that will protect it from rain, snow, and wind. This means that another huge stage of construction is complete, and our house is getting closer to being occupied.
grup basına çıkar koydum. Buradaki Bırak zahmetler iyice var.
In the previous stage, we completely completed the roof. We installed the rafter system, laid waterproofing, laid the sheathing, and covered the house with metal roofing tiles. Now the house is reliably protected from rain, snow, and wind. But to ensure it's truly warm and comfortable to live in, the ceiling under the roof must be properly insulated. Many people underestimate the importance of this stage. In fact, a very large amount of heat can escape through the roof, sometimes up to 30–40% of a house's total heat loss. If insulation is done incorrectly or with errors, the house will cool down quickly in winter, and the heating will run almost non-stop. Therefore, ceiling insulation requires special attention and high-quality work. We begin work from the inside of the house. The first step is installing a vapor barrier film. This film plays a crucial role in the entire insulation system. Moisture constantly forms inside any residential building. Cooking, washing, showering, and simply breathing all create water vapor in a room. Warm air rises, and this water vapor rises with it. If unprotected, it begins to penetrate the ceiling structure and the insulation layer. This is especially dangerous for mineral wool. When the insulation becomes wet, it practically stops retaining heat. Moreover, over time, moisture can lead to the growth of mold or mildew. That's why a vapor barrier is always installed first. It prevents moist air from the room from penetrating the insulation. We roll the film over the ceiling joists, starting at one edge of the room and gradually moving outward. The sheets are laid with a slight overlap. We secure the film directly to the wooden beams with a construction stapler. But there's one very important point here. Simply securing the film isn't enough. It's essential to seal all joints. We seal each joint between the film sheets with a special sealing tape. We also additionally seal the corners and joints with the structure using a special sealant or vapor barrier mounting tape. This is done to create a completely sealed layer. Even small gaps can become a source of vapor leakage. Therefore, all joints are sealed with the utmost care. Once the entire vapor barrier film is installed and completely sealed, we can move on to the next step, sheathing the ceiling boards. From below, we begin sheathing the boards along the ceiling joists. This process is carried out gradually, board by board, covering the entire ceiling area. The boards are attached to the joists with screws or nails. The sheathing serves several functions. First, it securely holds the film in place. Second, it creates a solid foundation for the entire ceiling structure. Thirdly, it will serve as the base for the subsequent interior finishing. When the entire lower section of the ceiling is covered with boards, the structure becomes much more rigid and reliable. After this, we can move on to the most important stage, installing the insulation. We use mineral wool for insulation. It is one of the most common materials for insulating roofs and ceilings. It has several key advantages. It retains heat well, is fire-resistant, resistant to temperature fluctuations, and is relatively easy to work with. The mineral wool is laid on top, between the ceiling joists. The insulation boards are cut to size and carefully inserted into the space between the joists. It is crucial to lay the insulation tightly, eliminating any gaps. Gaps between the mineral wool boards will allow cold air to pass through, significantly reducing the effectiveness of the insulation. Therefore, we strive to fit each board as precisely as possible. At the same time, the insulation should not be compressed too much. Mineral wool works by trapping air within its structure. If it's pressed too hard, it will lose some of its thermal insulation properties. We gradually lay the insulation over the entire ceiling, filling all the gaps between the joists. This stage requires care and attention, as it is the insulation layer that will retain the heat inside the house. But even after the mineral wool is laid, the work isn't finished. The insulation must be protected with another layer of special film. This film is called a wind barrier membrane. It serves a different function than a vapor barrier. While a vapor barrier protects the insulation from moisture from inside the house, a wind barrier protects it from air and moisture movement from outside. Sometimes, cold air can form in the attic. If the insulation isn't protected, this air will draw heat out of the mineral wool layer. The wind barrier membrane prevents such loss. We roll this film over the insulation over the entire ceiling. The canvases are laid with a slight overlap. To prevent gaps from forming, the mineral wool is completely covered by a protective layer. The result is a multi-layer insulation system. At the bottom is a vapor barrier film that prevents moist air from escaping from the house. Then comes a layer of mineral wool, the primary thermal insulation material. And on top is a windproof membrane that protects the insulation from air movement. This design allows the insulation to work most efficiently. In winter, heat will remain inside the house, and in summer, the roof will heat up less. At first glance, insulating the ceiling may seem like a simple task, but in fact, it's crucial to follow the procedure and not skip a single step. It's these details that ultimately determine the comfort of living in the home. The main exterior walls are up, the roof is complete, the ceiling is insulated, and now it's time to work on the interior walls. They shape the layout of the house, dividing the space into rooms, hallways, bathrooms, and other spaces. In our case, the interior walls are also made of aerated concrete blocks. This is a comfortable, warm, and relatively lightweight material that can be worked with quickly and accurately. Before laying the interior walls, some preparatory work must be done. The very first step is precise marking. We transfer the house plan directly to the subfloor. For this, we use a tape measure, a spirit level, and a chalk line. We determine the location of the walls using the plan and mark the lines on the floor. It's crucial to check everything carefully: the distances between walls, the width of doorways, and the layout of the rooms. Once the marking lines are ready, we need to double-check the geometry. The walls must be level and positioned strictly according to the plan. If an error is made at this stage, it will be very difficult to correct later. Therefore, I double-check the measurements several times before moving on to the next step. The next step is preparing the base. The subfloor must be clean and level. We remove dust, debris, and anything unnecessary so that the mortar adheres well to the base. Sometimes, a cement sand mortar is used for the first row because it helps compensate for minor floor irregularities. Now we can begin laying the first row of interior walls. The first row is the most important, as it determines the evenness of the entire future wall. A layer of mortar is applied to the markings, after which the first aerated concrete block is laid. It is imperative to check it with a level in several directions at once. The first block is positioned as precisely as possible. After this, the remaining blocks of the first row are installed. A neat joint is maintained between the blocks, and each new element is leveled with a rubber mallet. It is crucial to ensure that the entire wall line is level. Particular attention is paid to doorways. In places where doors will be, the required opening size is left. Typically, not only the door itself is considered, but also the space for the future door frame. When the first row is completely laid, it is checked again with a level and a straightage. If everything is level, you can proceed to the next step. Starting with the second row, the masonry is usually laid using a special adhesive for aerated concrete blocks. This adhesive is applied in a thin layer and allows for neat joints. Furthermore, a thin joint reduces heat loss and makes the wall stronger. Before laying each new row, the surface of the previous row is lightly smoothed with a special float for aerated concrete blocks. This helps eliminate minor irregularities and create a level base. Afterwards, the surface is cleaned of dust. The adhesive is applied with a notched trowel or special carriage. It is evenly distributed over the surface of the block. Then the next block is installed. Each element is carefully pressed and leveled. It is very important to maintain the joint overlap. This means that the vertical joints between blocks should not overlap in adjacent rows. Typically, each new row is offset by approximately half a block. This overlapping makes the wall much stronger. Gradually, the walls begin to rise higher. If a block needs to be adjusted to size, it can easily be cut with a special saw for aerated concrete blocks. The material is quite easy to cut, so fitting it is usually straightforward. Another important point is the fastening of the interior walls to the exterior walls. To ensure the walls function as a single structure, they need to be connected. For this, metal anchors or special perforated plates are used. They are installed in the masonry joints and connect the interior wall to the exterior wall. These fastenings are installed every few rows of masonry. This will prevent the interior wall from separating or cracking over time. When the masonry reaches the level of the doorways, lintels must be installed. A lintel is an element that supports the masonry above the door. For this, you can use prefabricated concrete lintels or install reinforcement and pour concrete. The lintel is installed so that it rests on the wall on both sides of the doorway. After the lintel is installed, the masonry continues. Gradually, all interior walls are raised to the desired height. At this stage, the house begins to fully take shape from the inside. The future rooms, hallways, and layout of all spaces can now be clearly seen. After the masonry is complete, the walls are checked with a level and a straightage. If there are any minor imperfections, they can be lightly sanded with a float for aerated concrete blocks. Proper utility lines are also usually planned at this stage. It's quite easy to make grooves for electrical wiring or pipes in aerated concrete blocks. Therefore, locations for outlets, switches, and other elements can be marked in advance. When the interior walls are fully laid, the house takes on a completely different appearance. Whereas before, it was just a large box, now a fully functional layout emerges. The interior walls are what truly transform a house into a living space. Separate rooms, a kitchen, a bathroom, and a hallway appear. And you can already imagine what the future interior will look like. Thus, step by step, we built all the interior walls from aerated concrete blocks, from the layout and the first row to the final rows of masonry and the lintels above the doors. We apply a special primer to aerated concrete walls to strengthen the surface and improve the adhesion of the plaster to the wall. The primer also reduces the block's absorption, allowing the plaster to adhere evenly and hold much more firmly. Once the primer has completely dried, you can move on to the next step, applying the plaster. This is a crucial step because once the windows are installed, the house is protected from wind, rain, and cold, and interior work can now proceed safely. First, we prepare the window opening. The surface must be clean and level. We remove dust and mortar residue and check the opening dimensions to ensure the window fits perfectly. It's crucial to leave a small installation gap around the perimeter, usually about 2 to 3 centimeters. This gap is needed for the foam, which will hold the window in place and provide thermal insulation. The next step is preparing the window itself. First, the sashes and glass units are removed to lighten the frame. This leaves only the window frame, which is much easier and safer to install in the opening. After this, the frame is carefully placed in the window opening. Using a level, we align it vertically and horizontally. For precise installation, special plastic or wooden wedges are used. These help secure the frame in the desired position. When the window is perfectly aligned, it is secured to the wall. Anchor bolts, or special mounting plates, are used for this. Fastening is performed around the entire perimeter of the frame to ensure a secure fit. After the frame is secured, the mounting gap between the wall and the window is filled with foam. The foam not only secures the window but also provides good thermal and acoustic insulation. Once the foam is cured slightly, the double-glazed windows and sashes can be reinstalled. The window is finally assembled, and its operation is checked to ensure the sashes open and close smoothly and without distortion. Once the aerated concrete walls are fully finished and the surface has been primed, plastering can begin. This step is crucial because it not only improves the home's appearance, but also provides additional protection from moisture, wind, and temperature fluctuations. First, we apply a base coat of plaster. This evens out the wall surface and prepares it for the subsequent decorative finish. The plaster mortar is applied in an even layer over the entire facade surface. Workers distribute it over the wall and carefully level it with a straight edge to eliminate any unevenness. It's crucial that the base coat be smooth and durable, as it will be the layer on which the decorative finish will be applied. After applying the plaster, the walls need time to set and dry. Once the base coat is completely ready, we can move on to the next step, applying the decorative plaster. In our case, we chose white decorative plaster, which will give the house a neat and modern look. We'll apply it using a compressor. This method allows us to quickly and evenly cover large areas. A special gun is connected to the compressor, and the decorative solution is sprayed onto the wall surface. Gradually, section by section, the white decorative plaster covers the entire facade of the house. This application method creates an interesting surface texture that looks neat and beautiful. Once the work is completed, the house is immediately transformed.
That's it.
The main construction is already complete. The foundation is ready, the walls are built, the roof is on, and the windows are installed. The house is completely closed, meaning we can now calmly begin the interior finishing. Renovations always begin with preparation. First, we carefully inspect all the rooms, checking the walls, floors, and ceilings. At this stage, it's important to understand what work needs to be done first, where the utilities will run, where additional wall alignment will be required, and what materials will be used. Next, planning begins for all utility systems, electrical wiring, water supply, sewerage, and heating. All this work must be completed before the main finishing of the walls and floors begins. Gradually, the house begins to transform from just a box of walls into a real living space. Much work still lies ahead, laying utilities, plastering the walls, screeding the floors, installing the ceilings, and much more.
Потом тоже, блин, там 40 лет. Ссылку на кухню. Не розстріляли, так сказали.
This journey was long and challenging. It all began with an ordinary plot of land that first needed to be prepared, leveled, the foundation laid, and utilities laid. Step by step, the future home emerged. We built the foundation, raised the aerated concrete walls, installed the roof, insulated the ceiling, installed windows, and completed numerous other tasks. Each stage of construction required time, effort, and attention to detail. Sometimes we encountered difficulties. Sometimes we had to redo something or find new solutions. But it's precisely these moments that make the result even more valuable. Gradually, the house began to take shape. Rooms, a kitchen, hallways, and windows, now allowing sunlight to stream in, appeared. Then the interior work began plastering, preparing the walls, and planning all the utilities. The house gradually transformed from a simple construction site into a true living space. Looking back, it's hard to believe that just recently this was an empty lot. And now, before us stands a finished house built with great labor and effort. And most importantly, this house was built for our family. Of course, there will still be many minor details and adjustments to be made, as construction always leaves details that are gradually perfected. But the main and longest part of the journey has already been accomplished. Thank you to everyone who followed this process and supported us throughout the construction. I hope this experience was useful and interesting. And for our family, a new chapter begins life in a house we built with our own hands.